All right, good night, everyone. Those who are online presently, we're going to start in the next 10 minutes. So by about 10 past 8, we'll begin. And just to note, the cameras are fixed. So that issue we had last night, it's no longer. So things will be smooth running today. So we begin, start at 8:10 p.m. All right, so stay tuned. All right, good night, everyone. Let's get started. So, in tonight's session, we are going to look at two very important topics, matrices and vectors. We know matrices and vectors are questions we often see, or topics we often see in question 10 of the exam paper. Most students perform relatively well in the matrices. They often have challenges with the vectors, right? So what we want to do is to ensure that we understand both matrices and vectors extremely well. So when you get to 10 of the paper, that can be comfortable marks in the bag, right? Of course, your exam is on Monday, and every day we started last night, but we had some challenges last night, and that is now rectified. So every day up until the exam, so the last session will be on Sunday. So we're going to have 5 sessions. So the last session, this is the second session, day 2. So the last session will be on Sunday, and we'll be covering all topics, key topics we expect to see in the CSEC exam paper, and try to strengthen those topics so we can work towards getting distinction in math. Alright, so tonight we're looking at matrices and vectors, and don't forget everyone, make sure you like, share and subscribe. Tell your friends to hop on your live and benefit from the sessions, okay? So let's get into it. So with matrices, we know a matrix consists of curved brackets, and within those curved brackets we have numbers, sometimes we see letters called variables within those brackets, and they are called elements. So in this case we have 3 matrices. We have Q, R and S, and they want us to explain why. So we have to look out for questions like these. Explain why the matrix product QS is not possible. So product means multiplication. So we have here matrix Q, and we have S. QS simply means Q multiplied by S. So we want to set it up in the order stated. So Q first, which is 2, -1, 4, 3. And in matrix S, we have 2, 7, 4, -1, -8, and 9. And what we want to do is to explain why the product of those two matrices, why it's not possible. Now, when multiplying matrices, before we multiply matrices, we must ensure that they are compatible, meaning that those two matrices can be multiplied. To prove or show that there's compatibility, we have to look at the order of each matrix. So, matrix Q, as you all know, it is a 2 by 2 matrix. We have 2 rows and 2 columns. This here is a 2 by 2 matrix. Matrix S, this here we have 1, 2, 3 rows. So remember, your rows always run horizontally. So we have 1, 2, 3 rows, and your columns run vertically. So we have 1, 2 columns. So we have 3 rows and 2 columns. So this here it is a 3 by 2 matrix. So these two matrices cannot be multiplied because if we look at the orders, the two inner numbers of our orders are not the same. Two matrices can only be multiplied provided those two inner numbers are the same. And what that means, this here is of course row, this is column, this is row, and this is column. So what this is telling us here, this 2 will tell us that the number of columns of the first, and this 3 tells us the number of rows of the second. So basically what's happening here, the number of columns of the first is not equal to the number of rows of the second. So therefore those two matrices are not compatible, and we cannot multiply them. They can only be multiplied provided that the two inner numbers are the same. So that's part 1. So this here is proving that they are not compatible, right? So hence shown, right? So we explain why that matrix Q by matrix S are not compatible, not possible. Yeah? So they want us to state the order of the matrix product SR, so part 2. Now I'll put here not compatible or not possible. Alright? So part 2, they want us to state the order of the matrix product SR. So we have S, we have R, that's S multiplied by R, again the product of those two matrices. So we state what is our matrix S, which is 2, 7, 4, negative 1, negative 8, 9. So that is matrix S. And matrix R, we have 1, 6, negative 5, 4. So they want us to state the order of the matrix product SR. Meaning when we multiply those two matrices, what is the order of the end result? What is the result of SR? What is the order of that end result? So, if we have to multiply those two matrices, again, we ensure that the two matrices are compatible. And how do we look for compatibility? We ensure that the two inner numbers of your orders are the same. So, this matrix, as we saw, it is a 3 by 2 matrix, 3 rows, 2 columns. And this matrix here, as we know, it's a 2 by 2 matrix. 2 rows, 2 columns. Clearly, those two matrices can be multiplied now. As we clearly see, the two inner numbers are the same, which tells us the number of columns of the first matrix, which will be 2 columns, is equal to the number of rows of the second. So therefore, they can be multiplied, and the outer numbers, this 3, and that 2, the outer numbers will tell us what is the order of the end result. So when they ask us to state the order of the matrix product SR, the order of that matrix product will be a 3 by 2. So order of SR is simply 3 by 2. Okay? Let's look at part 3. So they want us to calculate the matrix product QR. It's important for us to know how to multiply matrices, how to add them, how to subtract them. Yeah? So, let us multiply those two matrices QR. So I'm going to erase, and let's look at multiplying those two matrices Q and R. So we have here part 3 QR. So we multiply, we want the matrix product QR. So we set it up in the order stated. So we have Q, whose elements are 2, negative 1, 4, 3. And R, whose elements are 1, 6, negative 5, and 4. And in multiplying two matrices, again, before you multiply them, you check to ensure that they are compatible, which will indicate that the two matrices can be multiplied. And you also identify what's the order of the end result. Okay, so what your end result will look like. What's the order of the end result? So, this here is a 2 by 2 matrix. 2 rows, 2 columns. This here is also a 2 by 2 matrix. 2 rows, 2 columns. Clearly, those two matrices, they are compatible. We can multiply them because the two inner numbers are the same. So it indicates they are compatible. We can multiply them. The outer numbers will tell us when we multiply those two matrices, our end result will be a 2 by 2 matrix. So it's always important when you're multiplying two matrices to ensure that they are compatible. We can multiply them, and what's the order of the end result. So identify what's the order of the end result. How do we multiply two matrices to get our end result as a 2 by 2 matrix? So how do we multiply? So multiplying matrices will occur as such. We're going to take the rows of the first matrix. Remember, your rows always run horizontally. And we're going to multiply by the columns of the second matrix. Remember, your columns run vertically, right? So in multiplying, I'm going to take my first 2 rows, the 2 rows of the first matrix, and I'm going to multiply by each column of the second. So, first row, first column. First row, first column. So I'm going to multiply 2 by 1. 2 is linked to 1, so I'm multiplying 2 by 1. And negative 1 is linked to negative 5. That's my first row, first column, right? First row, 2 is linked to 1, negative 1 is linked to negative 5. So, 2 multiplied by 1, so I'm multiplying 2 by 1, plus, always put that addition sign, I'm going to multiply negative 1 by negative 5. So 2 by 1 in brackets plus, don't forget that addition sign, negative 1 is linked to negative 5, so negative 1 by negative 5. So that's my first row, first column dealt with. So, second row, I'm taking my second row by my first column. So the first 2 rows with your first column, second row by my first column. So 4 is linked to 1 and 3 is linked to negative 5. Okay, so let's make a mistake. They say 4 is linked to 1 and 4 is linked to negative 5. No. 4 is linked to 1, 3 is linked to negative 5. So you're going to multiply 4 by 1 plus, don't forget that addition sign, you're going to multiply 3 by negative 5. So don't forget your big brackets. So what I have here will be my first 2 rows by my first column, top, bottom. Yeah? Let's take my 2 rows, first 2 rows by my second column. So, first row, second column. So 2 is linked to 6, negative 1 is linked to 4. So 2 is linked to 6, so that's 2 by 6 in brackets, plus, don't forget your addition sign, negative 1 is linked to 4, so negative 1 by 4. That's my first row, second column. Now my second row, second column. So 4 is linked to 6 and 3 is linked to 4. So 4 is linked to 6, so that's 4 multiplied by 6 plus, don't forget your addition sign, 3 is linked to 4, so I'm going to multiply 3 by 4. Close big brackets. Let us simplify now. So we are going to get here. So we see when a 2 by 2 matrix as the end result, it's standard form. So this will become what? 2 by 1 is 2 plus negative 1 by negative 5 is 5. 2 by 6 is 12 plus negative 1 by 4 is negative 4. And I'm going to put negative 4 in brackets to separate my 2 signs. 4 by 1 is 4 plus 3 by negative 5 is negative 15. And I put negative 15 in brackets to separate my 2 signs. 4 by 6 will be 24 plus 3 by 4, 12. So therefore, when they ask us to calculate the matrix product QR, our end result will be 2 plus 5 is 7. A plus by A minus is A minus, so we know 12 subtract 4 will be 8. A plus by A minus is A minus, so that's 4 subtract 15, which will be negative 11. And 24 plus 12 will give us 36. So when they ask us to calculate the matrix product QR, this is what we are supposed to get. So we're going through some past paper questions, trying to strengthen our understanding. When you see questions as such, you know that's easy marks in the bag. You don't want to throw away questions as marks as for such questions. Easy, straightforward questions. So we want to make sure we can capitalize on that, alright? Let's look at another. Now we can see a matrix question where we have what we call a matrix equation. So this is an example of a matrices question where a matrix equation is involved. So this P plus Q equal to R is a matrix equation. And what we want to do is to use that matrix equation to find the unknown quantities, A, B, and C. You know in mathematics, anytime you're solving for an unknown quantity, you must create an equation to solve for that unknown quantity. So we want to find 3 unknowns, A, B, and C, and to do so, we have to use an equation, this matrix equation, to help us to find it. So, let's use the matrix equation to help us to find A, B, and C. So, we state our equation, P plus Q is equal to R, and of course we're going to set it up based on the order, so I'm going to place under P the matrix P, which is 3, negative 9, A, and 7, plus matrix Q, negative 1, B, negative 4, 1 is equal to R, whose elements are C, negative 3, negative 4, 8. So what we have here, this is a matrix equation, an equation involving matrices. Good? And what we want to do is to use this matrix equation to find the unknowns. So how are we going to use it? On the left of the equal sign, we're adding these two matrices. So you're testing the knowledge now of adding matrices. So we're adding these two matrices. So to add these two matrices, and these two matrices can be added because they are the same order. You can only add or subtract matrices provided they are the same order. When it comes to multiplication, they do not have to be of the same order, but they must be compatible. So again, look at the two inner numbers of the orders, right? When you multiply. So in this case, we can add these two matrices. So let's add them. This is a 2 by 2, this is a 2 by 2. So we're going to take first element plus first element, 3 plus negative 1 in brackets, first plus first. Second plus second, this is negative 9 plus B. So let me make my B better. This is third plus third, this is A plus, and I'm going to put negative 4 in brackets. Remember, to separate signs, you always separate by using brackets, okay? And this will be 7 plus 1, 4 plus 4. And this will be equal to, so I'm maintaining what is on the right, which is the matrix R, C, negative 3, negative 4, 8. So, let us simplify further what we have on the left, that matrix on the left. So this is, of course, a plus by a minus is a minus. So, you know, 3 subtract 1 will give us 2. This is negative 9 plus B. A plus by a minus is a minus, so this is A, subtract 4, and 7 plus 1 is 8. And this will be equal to C, negative 3, negative 4, 8. So in order for us to find for A, B, and C, what we're going to do here is to create some equations that help us. That's how you're going to solve for the unknowns. You have to create equations. So look how we're going to create equations here. Simple equating will take place. If you look, first is equal to first. So it means 2 will be equal to C. So already we found C. So 2 is equal to C. So you have one equation, and that's an equation. We have one equation, but we have the result for C. C is equal to 2. We can easily find the B now. We can create another equation to solve for B. This is our equation here. Negative 9 plus B. And keep in mind, we cannot add negative 9 and B. These are not like terms. Some students will write negative 9b. These two cannot be added. So please don't add them. Don't write negative 9b. These two are not like terms. So this stays as is. So negative 9 plus b is equal to negative 3. So I have a second equation here. And what I'll do one time, I'm going to solve for b one time. So this is a simple equation where I can find b. So to find b, to get b as a subject, is for b to stand alone, and we're going to be looking at the early part of the paper, questions in relation to the early part of the paper where you'll see all your equations, simultaneous, factorization. So later on in the week, we'll get into those. But simple equation, let's solve here. So we're going to, I'm going to remove negative 9. So I'm going to add 9 to both sides. So I like to use the balancing method. Some students may take negative 9, bring it over to the right and change the sign, no problem. So negative 9 plus 9 is 0. So b is equal to negative 3 plus 9, which is 6. So far we have found C and we have found B. So let us now find the value of A. So how are we going to find the value of A? Straightforward. We're going to say third, A minus 4, and keep in mind, don't subtract these two, this stays as is. a minus 4 is equal to negative 4. Third is equal to third. So I can say a subtract 4 is equal to negative 4. And of course we can solve that equation to find a. So therefore this is negative 4 plus 4. And what I do to one side, I do to the other. This is negative 4 plus 4. So my two negative 4s on the left will be 0. I'm going to get a by itself. And negative 4 plus 4 is 0. So I found a, b, and c. So we can say a is equal to 0, b is equal to 6, and c is equal to 2. So we have found for a, b, and c. So look out for questions like these where can be given a matrix equation and you have to use it to solve for what is required. Yeah? Alright, let's look at another example of different type of questions we can see involving matrices. Alright, let's look at this here. Right, so we need to pay attention to questions involving what you call a singular matrix and a non-singular matrix. Good, very common questions you see in the exam. And the first part of this question is one where we're talking about a singular matrix, and what we want to do is to find the value of x. Yeah? So let's find the value of x, knowing that that matrix is a singular matrix and what we should know for a singular matrix. So let me erase. So, and I'm sure we all know what's a singular matrix. I'm sure. We all know what's a singular matrix. Or when a 2 by 2 matrix is considered to be a singular matrix. So remember, for a singular matrix, so don't forget this. If you have a 2 by 2 matrix, A, B, C, and D, right? The matrix becomes singular and it's only applicable to a 2 by 2 when the determinant of that matrix is equal to 0. And I hope you know what's the determinant. So the determinant is when I multiply A by D, so this will be AB, subtract, I'm going to multiply B by C. So AD subtract BC, and when your determinant, remember this is called the determinant, so this is your determinant, when your determinant, when that is equal to 0, so when AD minus BC is equal to 0, then that matrix is said to be a singular matrix. So a singular matrix is one where the determinant of the matrix, 2 by 2 matrix, AD minus BC, that's the determinant. When that is equal to 0, then the matrix is said to be singular. But they want us to find x. So to find x, it means you have to create an equation. Remember, we just have to find A, B, and C, and we have to create equations to find for those unknown quantities. So the same thing here, we want to find x, which is an unknown, so we have to create an equation. So this is your equation here. AD minus BC is equal to 0 is your equation. And you're going to use that equation to help you to find x. So look how simple. So we are given this matrix, this 2 by 2 matrix, whose elements are 3, x, 2, and 4. Good? So of course this is A, B, C, and D. And we want to determine what is x. So we know for a singular matrix, the determinant is equal to 0. So what are we going to do? We are going to replace A with 3 in brackets. I'm going to replace D with 4 in brackets. Subtract, I'm going to replace B with X in brackets. And I'm going to replace C with 2 in brackets. And that is equal to 0. And what we are forming is a simple equation to find or solve for x. So 3 by 4 is 12, subtract all my subtraction sign. X by 2 gives me 2x is equal to 0, and I have a simple equation where I'm going to solve for x now. So how am I going to solve for x? So again, I need to remove this positive 12, so some students will take positive 12, put it over on the right, change the sign, no problem. I like to use the balancing method, so this is what? 12. So remove this 12, I have to subtract 12 from positive 12, so always carry out the opposite in operation. Subtract 2x, and the equation is about balance, so what you do to one side, you do to the other, we subtract 12 from 0. 12 subtract 12 is 0, I'm left with negative 2x. 0 subtract 12 is negative 12. And therefore I can solve for x by making x the subject. I'm going to divide both sides by negative 2. This is negative 2 multiplied by x. The opposite of multiplication is what? Division. So what I do to one side, I divide negative 2x by negative 2. I divide negative 12 by negative 2. My two negative 2's divide into each other to give me 1, and hence I'm left with x. And negative 12 divided by negative 2 will give me positive 6. So the value of x, if I replace x with 6 and I multiply AD, subtract BC, I'm going to get 0, proving it is a singular matrix. Good? So for a singular matrix, the determinant is equal to 0. And note, for a non-singular matrix, the determinant is not 0. Alright, so make sure you understand what occurs for a singular matrix, and make sure you understand what occurs for a non-singular matrix. So let's look at part C. Part C, N and P are 2 by 2 matrices. So N and P, determine NP is the multiplication. You can do that with our eyes closed. So this will be what? Let me erase here. So we're multiplying N and P, so we have NP. So we set it up in the order. We know N is 4, 1, 3, 2. P is 1, 5, 2, 1. Before you multiply, check for compatibility. Yes, this is a 2 by 2. This is a 2 by 2. The two inner numbers are the same, which means they are compatible. We can multiply them. The outer numbers, the end result is a 2 by 2 matrix. Good? Let's multiply those two matrices to get the result. Rows of the first by the columns of the second. Good? So how do we multiply two matrices? I'm taking the rows of the first by my columns of the second. So I'm going first row, first column. 4 is linked to 1, so that's 4 by 1 in brackets, plus, don't forget your addition sign, 1 is linked to 2, so that's 1 by 2. First row, first column dealt with. Second row, first column, top, bottom. Second row, first column, 3 is linked to 1, 3 by 1, plus 2 is linked to 2, so that's 2 by 2. So first two rows by my first column dealt with. So first two rows by my second column. So first row, second column. 4 is linked to 5, 4 by 5, plus 1 is linked to 1, 1 by 1. Of course, both placed in brackets. Then my second row by my second column, 3 is linked to 5, so 3 by 5, plus, don't forget your addition sign, 2 is linked to 1, 2 by 1. So let me simplify that. What are we going to get? This is 4 plus 2, 20 plus 1, 3 plus 4, 15 plus 2, which will give us 6, 21, 7, and 17. So that's the result for NP. So we have another part, part 2. Given that Pn is equal to 19, 11, 11, 4, determine whether matrix multiplication is commutative. And they love to bring questions in relation to the commutative law. And you need to understand what is the commutative law and if matrix multiplication is commutative. So we need to understand for the commutative law, we need to understand that This is the commutative law. If I multiply, commutative law of multiplication. If I multiply 2 by 3, it's the same as when I switch them around, I get the same result as 3 multiplied by 2. So 2 by 3 is 6. Switch them around. 3 by 2 gives me 6. So we want to determine if the commutative law is applicable to multiplication of matrices. And we saw when we multiplied n by p, this is the result we got for np. So this is np. And it says now, given Pn, look at Pn. Pn, the matrix is what? 19, 11, 11, and 4. So determine whether matrix multiplication is commutative. If this is the result for Pn, and that is the result for Np, then clearly Np is not equal to Pn. And if Np is not equal to Pn, so you can take 2 by 2 matrices, multiply them as is, switch them around, change the order, multiply, you'll see where the products are not the same. And therefore, the commutative law does not apply to multiplication of matrices. So given that Pn is that, determine whether matrix multiplication is commutative. It is not commutative. Alright? So something you need to look out for, it's to bring this regularly in the exam, asking whether 2 matrices are commutative when you multiply them. Alright? So, very important. Determine n inverse. What is the inverse of a matrix? So I am very sure you are going to see in your exam on Monday the inverse. They love to bring this. Look at your past papers, look at the history of the exam papers. Please make sure you know how to find the inverse. You see n to the power of -1, it's the inverse of the matrix. You have to determine the inverse of matrix n. So we know, so we have matrix n here, and we want to determine the inverse of that matrix. So let me erase, and let's find the inverse. And I'm sure everyone who's viewing now can, in their minds, state what is the formula for the inverse of a matrix. I'm sure we all sitting now and saying, yeah, rattle it out, it's coming off the tip of your tongue easily. What's the inverse of a matrix? So let me see, right? So we have here they want us to determine n inverse. So n inverse So to find the inverse of a matrix, it is, make sure you know the formula, it is always 1 all over the determinant of the matrix, determinant of the matrix n. I mean, how to find the determinant of a matrix, AD minus BC, times multiplied by the adjoint of the matrix n, right? So adjoint of n. So we know what's the determinant. We know the determinant of a matrix, it's AD minus BC. But what is the adjoint? So if you have a 2 by 2 matrix, just to ensure we make sure that we know our adjoint very well. So if this is a matrix, 2 by 2 matrix, then let's call this matrix A. Then the adjoint of this matrix A will simply be, also remember to interchange A and D, so you interchange them. So where I see A, I put D, where I see D, I put A, interchange them. And you change the signs of B and C. So positive B becomes negative B, positive C becomes negative C. So that's your adjoint. So my formula for the inverse of a matrix, the inverse of this matrix n, will be 1 all over, we know what's the formula for the determinant, AD minus BC, multiplied by our joint, this 2 by 2 matrix here, which is D negative B negative C and A. Yeah? So 1 over your determinant times your joint. And we want to find the inverse of this matrix N. So we know that matrix N, let's go back to state what is matrix N. Matrix N is 4, 1, 3, and 2. Yeah? So you want to find the inverse of that matrix, 4, 1, 3, 2. So how are we going to find the inverse of that matrix N? Simply, this is A, B, C, and D. And let's substitute into our formula. This is 1 all over. I'm replacing A with 4 in brackets. I'm replacing D with what? 2 in brackets. Subtract. I'm replacing B with 1 in brackets. And I'm replacing C with 3 in brackets. Times multiplied by what's the adjoint of that 2 by 2. So I'm going to interchange A and D. So where I see 4, I'm going to put 2. Where I see 2, I'm going to put 4. Just interchange them. And you change the signs of B and C. This is positive 1. So it becomes what? Negative 1. And this is positive 3. It becomes negative 3. So remember, you're only interchanging A and D, but you are going to change the signs of B and C. So this is 1 over my determinant times my adjoint. And let me further work it out. This becomes 1 all over 4 by 2 is 8. Subtract 1 by 3 is 3. Times my adjoint 2, negative 1, negative 3, 4. This becomes 1 all over 8 subtract 3 will be 5. Times 2, negative 1, negative 3, 4. And of course, my final step here will be to implement what we call scalar multiplication. This is where you have a number located outside of the matrix and we're going to multiply by each element within. So I'm going to multiply 1/5 by 2 and 1/5 by 2 over 1 will be 2 over 5. I'm going to multiply 1/5 by negative 1, so that will be negative 1 all over 5. I'm going to multiply 1/5 by negative 3 over 1, which is negative 3 over 5. And I'm going to multiply 1/5 by 4 over 1, which is 4 over 5. And that there is your answer for the inverse of it. So we have n inverse. Okay? So let's make sure. Don't forget that formula because I'm pretty sure you're going to see in that exam on Monday, they're going to ask you to find the inverse, and that is easy marks in the bag. Good? So you should know your formula. Alright, let's move on to part 4. Now, part 4. This here is, that's a matrix equation, which stem from a pair of equations you are to solve simultaneously. So you can solve a pair of equations simultaneously using a method of matrices. And what this is here basically is us using a method of matrices to solve for two unknown quantities, x and y. You know, when you solve a pair of equations simultaneously, that's what you're solving for. So we are going to use this matrix equation here to find x and y. So how are we going to use the matrix equations? What I'll do, let me write the inverse of n because I have to use the inverse of n to help me with solving for x and y, which you'll see shortly. So this is 2/5, negative 1/5, negative 3 over 5, and 4 over 5. Alright? So I state the inverse of n. So let's look at part 4. So they ask us to calculate the values of x and y given that matrix equation. So we have 4, 1, 3, 2. We have xy is equal to 1, 2. And we're going to see when we're doing 1 or 2 more questions involving matrices. Remember, we're doing vectors today too, where we'll be given a pair of equations to solve simultaneously using matrices, and we have to convert it into a matrix equation looking like that. So we'll look at 1 or 2 examples like that also to make sure we see it in that form, we can treat it accordingly. Yeah? So this here, after, of course, we have our matrix equation. I'll always advise, label each matrix. So you know, if you look previously, 4, 1, 3, 2 is this matrix N here. Alright? So I'm going to call 4, 1, 3, 2 N. XY will be my unknowns, which is represented by X. And I'm gonna name the matrix 1, 2, B. So to solve for X and Y unknowns, which is represented by X, I need to make X a subject, meaning I have to get X by itself. So to get X by itself, I am going to remove N. See that N needs to go. And to remove N, it comes across to the right of the equal sign as N inverse, which we just calculated. See this here? This will come into play to help us to find X and Y. So when I remove N, so I can make X a subject to make X standalone, which represents X and Y. When I remove N comes across to the right of the equal sign as N inverse, N to the power of -1 multiplied by B. And I must place N inverse in front of B. Students, please don't make a mistake and write N inverse after B. Okay? Sometimes students make that mistake. Huh? N inverse has to be in front of B because, remember, N is a 2 by 2 matrix. The inverse of N is also 2 by 2. B is a 2 by 1 matrix. We have 2 rows, 1 column. We'll be seeing that. So that's a 2 by 1 matrix. And the only way these two matrices can be multiplied, and why N inverse has to be in front of B, is they are what? Compatible. If you had N inverse after B, will they be compatible? Clearly not. Yeah? So, when you bring N over to the right of the equal sign to make X a subject, where X represents the unknowns X and Y, then N comes across to the right as N inverse, which is placed in front of B, or we say it's pre-multiplied by B. Pre-multiplied, right? So, let's work it out. X represents XY. N inverse, we calculated that previously, so no need for us to repeat the process to go work it again. We have it there. So it's 2 over 5, -1/5, -3/5, and 4/5. Good? Times the matrix B, whose elements are 1, 2. So again, what you know to multiply matrices, this should be pretty straightforward. Let's make sure we can multiply our matrices. Again, before you multiply matrices, check to ensure that they are compatible. This here is a, realize they're not of the same order, but they can be compatible by checking the orders. This is a what? 2 by 2. This is 2 rows, 1 column, 2 by 1. The two inner numbers are the same. So it means that they are compatible. We can multiply them. And the outer numbers will tell us when we multiply those two matrices, our end result will be a 2 by 1 matrix. Your end result will look like this one here, 2 by 1 matrix. Where you can get a value for X and get a value for Y, one time. So, let's multiply. How do we multiply two matrices? Easy. We take the rows of the first. I like to highlight them. You can also if you want. And you're going to multiply by the only column. So let's multiply. Let's see what we're going to get. And this is going to make it easier when you see the denominators, in the, especially when you have fractions. Students start quiver when they see fractions. So make sure with your fractions, especially when you're multiplying inverse by b, it's better when you see all the denominators are the same. It's going to make it easier to get the final result. So look at it here. This is first row by my only column. 2/5 is linked to 1, so that's 2/5 multiplied by 1 plus, don't forget plus, the addition sign, negative 1/5 is linked to 2. So that's negative 1/5 times 2. So that's my first row by my first column dealt with. Now, second row by my only column, right? This is negative 3/5 is linked to 1, so that's negative 3/5 by 1 plus, don't forget your addition sign. 4/5 is linked to 2, so that's 4/5 times 2. Don't forget your big brackets, right? Must have those big brackets. A matrix must have brackets, alright? So, and you'll see why the denominators is easier when the denominators are the same. Look at it here. This will be 2/5 multiplied by 1 over 1 will be 2 over 5. Plus negative 1/5, negative 1 over 5 multiplied by 2 over 1, negative 1 over 5 by 2 over 1 will be negative 2 over 5. And I'll put it in brackets to separate the two signs. Negative 3/5 by 1 is negative 3/5 plus 4/5 multiplied by 2, 4 over 5 times 2 over 1 will give you 8 all over 5. Yeah? And therefore, what's going to happen here? So we solve it for x and we solve it for y. So let's break it down now. Once the denominators are the same, you know a plus by a minus is a minus, so it's 2/5 subtract 2/5. Yeah? And 2/5 subtract 2/5, obviously that's what? 0. Yeah? And negative 3/5 plus 8 over 5. So when the denominators are the same, all we need to do is to work out what is in the numerator and of course maintain your denominator. So negative 3 plus 8 will give us 5, and this occurs only because the denominators are the same. You can't do this. You maintain your denominator 5, and you know negative 3 plus 8 will give us 5. So your answer here is 0, 1. And therefore you have found your value for x. X will be equal to 0, so therefore x is equal to 0 and y will be equal to 1. Alright, so make sure you know you are familiar, because you know I'm confident enough that you can see a question like this, because if you look at the history of the papers, you will see where questions involving the matrix equation would stem from a pair of equations that you have to solve simultaneously, that matrix equation, or the whole simultaneous solving a pair of equations simultaneously using matrices. That is very common in the CSEC exam paper in relation to matrices. So make sure we understand it well. Alright? Okay, so let's see what we have next here. Alright? So again, same thing, same concept. Right? With this question here, let me erase. So same concept here. Of course, we're adding these two matrices, multiplying. This is 2 by m, so multiplying 2 by all the elements in matrix m. You're going to add it to L, so additional matrices, and a bit of and your multiplication of matrices come into play here. So I can do the L plus 2m, but of course Lm we can do comfortably. So L by m. Look again. This is always a questions that bring regularly in the exam. Q to the power of -1, find the inverse of Q. And again, look, matrix equation where we have to find x and y. So what I'll do here in this question, I'll just simply look at L plus 2m, and let's see, this here. We're going to look at this question next. Very important question. Very, very important question. We're going to look at this question. Yeah? So, you see this M inverse by M is equal to I, your identity matrix. Let's make sure, class, that you know that proof. Any matrix by its inverse gives us the identity. So, we're going to look at that. So, let me quickly do L plus 2M, and then we get into that question next. Alright? So strengthening our understanding to make sure when we see that matrices question in the exam on Monday, it is guaranteed marks, okay? Guaranteed. So we have matrix L. Let's treat with this here. So we only doing L plus 2M, this one. So we have matrix L, whose elements are 3, 2, 1, 4. We have matrix M, whose elements are negative 1, 3, 0, and 2. And they want us to find L plus 2M. Okay? So of course we're adding those two matrices, but we have 2M. And what is 2M? 2 here is called a scalar. So you're going to multiply 2 by all elements within matrix M. So what I'll do, I'll work out 2M first, and then we're going to add that matrix to L, maintaining the order in which it is stated. So 2M, it's simply 2 times the matrix M, negative 1, 3, 0, 2. And we're going to multiply 2 by each element within. 2 by negative 1 is negative 2. 2 by 3 is 6. 2 by 0 is 0. 2 by 2 is 4. So we have 2M. 2 by each element within the matrix M. And what we're going to do is add this matrix to your matrix L. So you have L plus 2M. L, it is 3, 2, 1, 4 plus 2M, negative 2, 6, 0, 4. Clearly, we can add those two matrices because they are of the same order. If two matrices are not of the same order, you cannot add them, nor can you subtract them, alright? So they must be of the same order to add or subtract them. So, let's add first plus first. You're not saying rows by columns here. This is first plus first, second plus second, third plus third, fourth plus fourth. Alright, so that's what we're doing. So this is 3 plus negative 2 in brackets. This is 2 plus 6. This is 1 plus 0. And this is 4 plus 4. And we have our end result. Of course, the end result will also be 2 by 2. So this is a plus by a minus is a minus. 3 minus 2 is 1. 2 plus 6 will be 8. 1 plus 0 is 1. 4 plus 4 is 8. Good? So that is L plus 2M. So you work out 2M first, take the scalar 2, multiply by each element within the matrix M, and then you add, and you, of course, get your result. So let's move on to this question, and then I'll probably do one more on matrices. Let me see which one I'll do. Right, we look at this one here, solving the pair of equations simultaneously using a matrix method. So we'll do that last, and then we get into some vectors, alright? So look at some vectors next. Alright, so I'm going to erase. And let's look at this important question. Especially this part here, M inverse times M. Right, now let's read the first question. So the value of the determinant of M, 2, 3, negative 1x is 9. Good? So the value of this determinant, when you work out the determinant of that matrix 2, 3, negative 1x, we are supposed to get 9 as our determinant, right? And what they want us to do, they want us to find the value of x. They wanted to find x. Good? So, how are we going to find x? You know, in mathematics, anytime you have to solve for an unknown quantity, you must create an equation. So you have to create an equation to solve x. What is the equation? The equation will be the determinant m, and we know how to find the determinant, we know what's our formula. The determinant of m is 9, it's equal to 9. Alright, and what this also tells us, this matrix M is a non-singular matrix. Keep that in mind, it's non-singular. It's non-singular because the determinant is not 0, the determinant is 9. So once the determinant is not 0, then that matrix is said to be non-singular. Alright? So this matrix M is a non-singular matrix, even though it's not stated, but we know because the determinant is 9. So we have M, 2, 3, negative 1x. Yeah, that's a matrix M. And the determinant of that matrix M is 9. We know how to find the determinant. What's the determinant? AD minus BC. Don't forget that formula. And that is equal to 9. What we have on the board here, this is an equation which we're going to use to help us to solve for x. Good? And keep in mind, because the determinant is 9, because you will see questions as such, because the determinant is not 0, whether it's positive or positive number or negative number, once it's not 0, then the given matrix is said to be non-singular. Alright? So this is a non-singular. So let's find x. So, creating my equation, this is A, B, C, and D. And let me substitute. I'm going to replace A with 2 in brackets. I'm going to replace D with X in brackets. Subtract. I'm going to replace B with 3 in brackets. And I'm going to replace C with negative 1 in brackets is equal to 9. Okay? So let's solve that equation for x. This is 2 by x is 2x. Subtract, hold a subtraction sign. 3 by negative 1 is negative 3. And of course, you separate your signs with brackets. I'll always advise that. Some students will say minus by plus, negative by 3 is negative 3. Then negative 3 by negative 1 is positive 3. No problem. But to be safe, because you know, make less mistakes, I believe, when you approach it this way. A by D, 2 by x is 2x. Hold the subtraction sign. 3 by negative 1 is negative 3. But you make sure you separate your signs by putting negative 3 in brackets is equal to 9. And you further simplify 2x, a minus by a minus is a plus 3 is equal to 9. And what can we do here now? We can easily solve for x. So I'm going to find x. I have to remove 3 first, not 2. So I'm going to remove positive 3 first. So I'm going to subtract 3 from both sides. So 3 minus 3 will be what? 0. You're going to get 2x is equal to 9 minus 3 is 6. And then I can divide both sides by 2. 2 times x. Of course, that's to multiply by x, and the opposite of multiplication is division. I divide 2x by 2, and what I do to one side, I do to the other. I divide 6 by 2. By 2 is divided into each other to give 1, and therefore x is equal to 3. So the value of x, when the determinant of that matrix is 9, indicating it's a non-singular matrix, the value of x is 3. And if you put 3 back inside here, replace x with 3, and you multiply a by b, subtract b by c, you're going to get 9 as your determinant. Alright? So, ensuring when we have to find unknown quantities, we know we must create an equation. Now, determine the value of m inverse. So that's easy. So let's find m inverse. We know x is what? 3. So we know this matrix M can be rewritten as 2, 3, negative 1, 3. So you want to find the inverse of m given x is equal to 3, which we just found, alright? So that is your matrix M. So let's find the inverse of that matrix. Let me erase. And we all should know how to find the inverse. Yeah? So we all should know how to find the inverse. Let me replace this x with 3. So you all know how to find the inverse. So let that formula register in your mind one time. So M inverse is 1 all over your determinant AD minus BC multiplied by the adjoint. Remember what is your adjoint? You interchange A and D, but you change the signs of B and C. So this becomes negative B, negative C. So please make sure you remember your formula for the inverse of a matrix. Good? So let's substitute. Let's find M inverse. This will be, M inverse will be equal to 1 all over. I'm replacing A with 2 in brackets. I'm replacing D with 3 in brackets. Subtract. I'm replacing B with 3 in brackets. And I'm replacing C with negative 1 in brackets. Times my adjoint. Now what's my adjoint? I'm going to interchange both A and D. So where I see 2, I'm going to put 3. And where I see 3, I'm going to put 2. And I'm going to change the signs of B and C. So this is what? Positive 3, so it becomes negative 3. And this is negative 1, so it becomes positive 1. So that is the adjoint of the matrix M. So 1 over your determinant times the adjoint. So let's further simplify. This becomes m to the power of negative 1 will be 1 all over. 2 by 3 is what? 6. And, well, of course, we know the determinant already is what? We know the determinant is 9 because it told us so in the early part of the question, right? So we don't need to, let's do it. Let's do it. So 2 by 3 is 6. Subtract 3 by negative 1 is negative 3. Good? Times your adjoint 3, negative 3, 1, 2. Yeah? So this becomes M inverse will be 1 all over A minus by A minus is A plus. 6 plus 3 is 9. 1 over 9 times 3, negative 3, 1, 2. And therefore, to get your final representation for the inverse, it's 1 over 9, 1 over your determinant, which is a scalar fraction, times the elements within the adjoint. So 1 over 9 by 3 over 1 will be 3 over 9. 1 over 9 by negative 3 is negative 3 all over 9. 1 over 9 by 1 will be 1 over 9. And 1 over 9 by 2 will give us 2 over 9. Alright? Now if you want to simplify, we see where fractions can be simplified. If you want to simplify, no problem. But what I would advise, because we're using M inverse in the third part, when we're using the inverse, use the inverse where all the denominators are the same. It's going to make it easier for you to get your result. So what I'll do, I'll simplify the inverse, the elements that need to be simplified, and you can represent the final representation for your inverse as 1 over 3, negative 1 over 3, 1 over 9, 2 over 9. Alright? But when we're using the inverse in part 3, which is very important, let's make sure we know part 3, right? We're going to use this 2 by 2 for the inverse where all the denominators are the same to make obtaining the result much easier. Alright? So, this here is the inverse of M, which we know how to do. So now let us use it to help us to prove this. Show that. Now in mathematics, anytime they ask you to show something, it's like a proof. You want to show that M inverse by M is equal to I. And I hope you know what's I. Was I? Yeah? I, it is known as the identity matrix. Good? So the identity matrix. So let me write the inverse of M on this side, and then I'm going to erase. So M inverse is 3 over 9, negative 3 over 9, 1 over 9, and 2 over 9. So I'm using that, not the simplified representation. So I'm going to erase. So what is right? They want us to show M inverse times M is equal to I. Now I is called the identity matrix. The identity matrix, and the identity matrix, it is a standard matrix represented as 1, 0, 0, 1. So that's a 2 by 2 or diagonal matrix. 1, 0, 0, 1. Standard 2 by 2 for the identity. And tomorrow I'll be doing a bit of transformations along with some quadratics and some linear programming. So I'll do that tomorrow. So you're going to see for transformations, you know, sometimes the identity matrix, well, the identity matrix comes into play heavily with that, with transformations, okay? So the identity matrix, make sure you know what that I stands for, and the matrix that is linked to I. Good? So we want to show when I multiply the inverse of a matrix by its given matrix. So the inverse of M, when I multiply M by its inverse, any matrix times its inverse will give us the identity. And it doesn't matter the order. It can be M inverse times M, or M times M inverse. Alright? Remember, for the commutative law will be applicable when it comes to the identity and multiplying matrices, especially for the identity, only for the identity. So M inverse by M or M by M inverse will give us the identity matrix. Now let's prove that. Let's show that. Let's show a matrix by its inverse will give us I. So M inverse is this matrix here, which is 3 over 9, negative 3 over 9, 1 over 9, 2 over 9. M is that matrix we have here, which is 2, 3, negative 1, 3. So remember, we got x to be 3, right? So let's multiply those two matrices and let's see if we're going to get 1, 0, 0, 1. So please make sure you know how to do that proof there. Sure. So let's multiply. So again, testing the knowledge of multiplying matrices. Both are compatible. Both are 2 by 2 matrices. So know they are compatible. So we are simply going to multiply rows by column. So this will be first row by my first column. 3 over 9 is linked to 2. So that's 3 over 9 times 2 in brackets. Plus, I'm going to put 2 over 1 plus. Negative 3 over 9 is linked to negative 1. So this is negative 3 over 9 times negative 1 over 1. So that's my first row by my first column. Let's take my second row by my first column. 1 over 9 is linked to 2. So that's 1 over 9 times 2 over 1 plus 2 over 9 is linked to negative 1. So 2 over 9 times negative 1. So that's my first two rows with my first column dealt with. Now let's take my first two rows with my second column. So first row, second column. So 3 over 9 is linked to 3. So 3 over 9 by 3 over 1 plus negative 3 over 9 is linked to 3. So that's negative 3 over 9 times 3 over 1. Right? So that's my first row, second column dealt with. Now, my second row, second column, let's see what we're going to get. This is 1 over 9 is linked to 3. So 1 over 9 times 3 over 1 plus 2 over 9 is linked to 3. So that's 2 over 9 times 3 over 1. Alright? Don't forget your big bracket. So let's simplify. Let's see what we're going to get. Of course, 3 over 9 by 2 over 1 will give us 2 by 3, alright, 6 over 9 plus negative 3 over 9 by negative 1 all over 1. A minus by a minus is a plus, so 3 by 1 is 3, positive 3 all over 9. Yeah? 3 over 9 by 3 over 1, this is a 3 by 3 is 9, so you're going to get 9 all over 9 plus negative 3 over 9 by 3 over 1 is negative 9 all over 9. And of course, I'll put that in brackets to separate my two signs. This is 1 over 9 by 2 over 1, that's 2 over 9 plus 2 over 9 by negative 1 over 1, that's negative 2 over 9. But I put negative 2 over 9 in brackets. 1 over 9 by 3 over 1 will be 3 over 9 plus 2 over 9 by 3 over 1 will give us 6 all over 9. Okay? And let's simplify to see if we're going to get this matrix here. Let's see. Alright, and once we get that matrix, then we have shown the matrix M times its inverse, or the inverse times matrix M will give us the identity. So this becomes what? 6 over 9 plus 3 over 9. Once the denominators are the same, it makes it easy. 6 plus 3 is 9, so that's 9 over 9, which is what? 1. A plus by a minus is a minus. 9 over 9 is 1, plus negative 9 over 9 is negative 1. So you're saying really 1 subtract 1. Yeah, 1 plus by a minus is a minus. 1 subtract 1, which is 0. A plus by a minus is a minus. So that's 2 over 9 subtract 2 over 9, which is 0. And 3 plus 6 is 9. 9 over 9 is 1. So, hence, shown. And after you show something, class, it's always important to write hence shown, right? So, hence shown. See, I've shown that the inverse of M times the matrix M gives you the identity matrix. Alright? Okay, so let's ensure that we're clear on that one, and I'm going to do the last question here on matrices, which is to solve the pair of equations simultaneously using a matrix method, and then we're going to jump into some vectors. All right. So I'm erasing here. So erasing all this, and let's look at that last question we're going to look at in relation to matrices. Making sure we can solve a pair of equations simultaneously using a method of matrices. So they want us to solve the following pair of simultaneous equations using a matrix method. So you know, you have 5x minus 2y is equal to 44. And I have 2x plus 3y is equal to 10. So I have a pair of equations I want to solve simultaneously. That's a pair of linear equations we want to solve simultaneously using a matrix method. So if you're using a matrix method, you have to see matrices. Right now I'm not seeing any matrices there. Good? So it means I have to throw some matrices in the mix, right? And I have to now create what we call a matrix equation, which we looked at previously. Yeah? So you see those examples of the matrix equations I spoke about previously. You're going to see that being created here. Look at how we're going to create it. We're going to take all the numbers located in front of the unknown quantities, x and y are the unknowns. So I'm going to place all those coefficients of the unknowns, the numbers in front of the unknowns, in one matrix. 5, negative 2, not just 2, but negative 2, 2 and 3, I place in one matrix. My unknowns x and y, I'm going to place in another matrix, is equal to 44, 10, another matrix. So you see a matrix equation created here, like what we did before. What I'm going to do, I'm going to, next step after I've created my matrix equation, I'm going to label each matrix. So you label each. So I'll call this A, I'll leave this as X, and that as B. Good? And we know to get X by itself, which represents X and Y, I need to remove A. So we know A will come across to the right as A inverse. So I'm going to put A inverse in front of my B. I have to pre-multiply A inverse by B, don't put it after. And in this case, I have to go work out the inverse now. It's not like the question we did before where we had the inverse. We did it in a part before. So in this case, we have to now find the inverse of A. So let's go find it. We know how to find the inverse. A inverse, 1 all the way on the determinant, times the adjoint, dA, negative B, negative C. You know that formula to find the inverse. You know this is A, B, C, and D. Let's substitute. This becomes what? 1 all over, replacing A with 5, D with 3, subtract B with negative 2 in brackets, C with 2 in brackets, times the adjoint of this matrix is going to interchange. So 3, 5, interchange both A and B, change the signs of B and C. Negative 2 becomes positive 2, positive 2 becomes negative 2. And therefore this becomes what? 1 all over, 5 by 3 is 15, subtract negative 2 by 2 is negative 4, in brackets times the adjoint. That will become 1 all over, so A inverse, 1 all over, A minus by minus is a plus, so 15 plus 4, 19, 1 over 19, times the adjoint 3, 2, negative 2, 5. And now we're going to multiply 1 over 19 by each of the elements within and keeping the same denominator. Well, nothing will be able to simplify that anyhow you take it. But this becomes what? A inverse 1 over 19 by 3, 3 over 19, 1 over 19 by 2, 2 over 19, 1 over 19 by negative 2, negative 2 over 19, 1 over 19 by 5, 5 over 19. Alright, so that's showing you to give you a simultaneous equation, a pair of equations. You have to solve simultaneously. You're not using elimination or substitution there. You wanted to use what? A matrix method, and this is the method we're going to use. So after I've found A inverse, let me now multiply A inverse by B so I can find X and Y. So this will be what? X, let me do it here, is equal to A inverse times B. X, of course, will be X and Y, which is what you want to find. A inverse will be what I have here, 3 over 19, 2 over 19, negative 2 over 19, 5 over 19. Good? A inverse times B is 4410. So let's multiply. Clearly those two matrices are compatible. Clearly the end result will be a 2 by 1 matrix. Now we know that. So let's multiply. Rows of the first by the only column. So I'm saying first row by first column. 3 over 19 is linked to 44, so that's 3 over 19 times 44 over 1 plus 2 over 19 is linked to 10, so that's 2 over 19 times 10 all over 1. So that's my first row, first column, or only column dealt with. Now my second row and my only column, negative 2 over 19 is linked to 44. So negative 2 over 19 by 44 plus 5 over 19 times 10. Yeah? And what are we going to get here? This will give us, so once the denominators are the same, is going to help with us getting your result easily. So this is what? 44 by 3, that is 132 over 19 plus 2 over 19 by 10 over 1, that's 20 over 19. Negative 2 over 19 by 44, that's negative 88 over 19 plus 5 over 19 times 10 over 1, that will be 50 over 19. And what are we going to get there? Of course, once the denominators are the same, we can easily maintain the denominator. And the numerator we can add. 132 plus 20 will give us 152 over 19. And negative 88 plus 50 will be negative 38 all over 19. Alright? And therefore what we're going to get as the final result. So therefore we know we can get x and y as, so let me continue up here. 152 divided by 19, that should give us what? That should give us 8. Yeah? So 8. And negative 38 divided by 19 will give us negative 2. So we have solved for x and y using a method of matrices. So therefore, x is equal to 8 and y is equal to negative 2. Yeah? So solving a pair of equations simultaneously using a method of matrices. So convert into a matrix equation, label, remove A, comes across as A inverse, place it in front of B, find A inverse. You know how to find A inverse, 1 over the determinant times your joint, and you multiply A inverse by B to give you your final result, which is 8 negative 2. Alright? So let's move on to one or two vector questions. So I hope when we see our matrices question in the exam, we can do it well, get full marks in our matrices question. So alright, so let's look at now some vector questions, alright? Right, so I'll start off with this this vector question. Now note with your vectors, you can see two types of vector questions in your exam on Monday, right? If they bring vectors, and if you look at the history of the exam, you know they bring vectors almost every year. So the two types of vectors you need to be conscious of vector questions. You can see one will be a vector question or what you call position vectors. And with position vectors, when we talk about position vectors, position vectors are vectors that start from the origin of a Cartesian plane. And a vector quantity must start somewhere and must end somewhere. Good? So for all position vectors, it starts at the origin. So you'll see for most position vectors, in fact all position vector questions, you will start with O. So once it's a position vector, you see where it starts with O, and of course you will end somewhere. And all vector quantities will have an arrow which will indicate the direction. So you're moving from starting to ending, and it's also going to have magnitude. And the magnitude for position vectors, and the magnitude means the size of the vector quantity, as what you call a column vector. A column vector is the same as a 2 by 1 matrix. A column vector looks like this. So that's your column vector. Yeah? So your column vector will look like that. So you see all these vectors here, 6, 2, 3, 4, 12, negative 2. They are all column vectors. And x in your column vector will simply represent your horizontal movement. So if this is my origin, x will be, if it is positive x, it means that I'm going to move to the right of the origin. If it is negative x, it means you move to the left of the origin. You move to the right of the starting point. If it's positive, you move to the left of the starting point if it is negative, right? And y simply represents, this is positive x here. Y represents your vertical movement, meaning that you're moving upwards, and if it's upwards, you can move up downwards as well too. If it's upwards, it's going to be positive y, and if it's downwards, it's going to be negative y. So this is an example of a position vector. And remember, this horizontal and vertical movement must create that right angular movement as you move from the starting point to the ending point. So all position vectors will stem from the origin of a Cartesian plane. And I always advise with a vector question, it's good to have a visual. So it's like in this question we're going to do it. We don't have a visual, but it's always good to set up a nice little sketch in your, when you have your paper, you set up a nice little sketch in that paper. Or if not, if you have graph paper, it might be even better to set it up on graph paper and have that visual to help you. So this vector here, this diagram I have here, this is my y-axis, x-axis. This vector here will be vector OA, and this is how we write it, state it. O is the starting point, A is your end point. So start with O, end with A, and I place my arrow on top of OA showing the direction from O to A. And the magnitude of this vector will be x is my horizontal and y is my vertical. Alright, so the magnitude represented as a column vector. So remember, x is not always positive, and likewise y. Depends on the direction, then we will, of course, attach a sign to it. Yeah? So let's look at this question here. So understanding this first, and then let's take it into the question. So let me erase here. So the points A, B, and C have position vectors OA, OB, and OC respectively. Expressed in the form xy. So I want your answer in terms of a column vector xy, the vector BA, and the vector BC. Alright? But we don't necessarily need a diagram or sketch to help us to find BA and BC. Right? I'll show you, another way we can obtain the result without a diagram. But I'll always advise that a visual is important. It's always good to have that visual. So let's place these three vectors OA, OB, and OC on a Cartesian plane. So have that visual. So this will be my y-axis, my x-axis. So I'll have here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I will have, let me put here 1, 2, 3, 4, 5. Let me put here -1, -2, -3, -4, -5. Let me put some on the negative x, -1, -2, -3, -4. So a simple setup of a Cartesian plane here. So this is my y-axis, x-axis. And you can do this simple sketch in your notebook, right? So, or you can put it on graph paper. Now, we have this vector whose magnitude, OA, whose magnitude is 6, 2. So how are we going to represent that? So we know O is our starting point, which is the origin. And I have A, so where's A going to end? Now, 6, 2 is not a point you're going to plot in. That's not a point you're going to plot. And when students see 6, 2, they feel it's a point you're going to plot. That's the movement of the vector. So positive 6 means you're going to move 6 spaces to the right. So 1, 2, 3, 4, 5, 6. And positive 2 means you're going to move 2 spaces upwards. 1, 2. So this here represents A, movement of the vector. 6 to the right, 2 upwards. So it's not a point you're going to plot. It's not this. That is a point you're going to plot. But you have a column vector, movement of the vector, right? So once I have found the position of A vector quantity must be drawn by connecting 2 points, starting, ending, and of course on that line I'm going to place the direction, which is indicated by an arrow, and of course you can put the magnitude as a column vector on the diagram too. So if you want to put 6, 2 here so you can see it, no problem. Alright, so that's the vector OA. Vector OB, the magnitude is 3, 4. So OB means I'm going to move 3 to the right, not a point you're going to plot, and 4 spaces upwards. 1, 2, 3, 4. That's the position of B, and what I can do now is connect O to B. So that's my vector OB, and I will have here my direction from O to B, and the magnitude, I can place the magnitude on my diagram 3, 4. Done? So you can see the magnitude on the vector quantity. Then you have the last vector there, OC, which is 12, -2. So it's not a point. Movement positive 12, so you're moving 12 to the right and 2 downwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 2 downwards. 1, 2. So this will be the position of C. And because it is a position vector, I must start from the origin. So I draw a line from O to C. Alright? And of course on that vector quantity I'm going to place my direction, and my magnitude of course will be 12, -2. Alright? So this here of course a diagram, right? A nice little sketch. So you have that visual. Now they want us to express in the form of xy as a column vector. They want us to find the magnitude of that vector BA. So for me to find the magnitude of the vector BA, the first thing I need to do is identify where is the vector BA on my sketch. So I'm seeing B and I'm seeing A here. So what I'm going to do first is connect B to A. So I connected B to A. So what I want to do is to find this vector BA. But of course, in order for it to become a vector, I have to put in what? Direction, because a vector quantity will have two things, direction and magnitude. So my direction will be from B to A. Alright? Now there are two ways we can find BA. Now, if we look, BA falls within a triangle, which we clearly see falls within a triangle. And with vectors, you're going to see when we look at the displacement vector, right? That's, you have position vectors, you have displacement vectors. So we're going to look at some displacement vector questions too. This is a position vector. So we know that once a vector quantity falls within a triangle, you all see this triangle here? Then we can use what we call the triangle law to help us to find BA. Alright? And from using this diagram, I'll show you how we can use the triangle law to find BE. Good? Now, in using the triangle law, it's just like, it's similar, kind of similar to like Pythagoras. You know Pythagoras, you have a triangle, and if you have to find the unknown side, you must have information for two other sides. You must have the lengths of two other sides to find the third side. So think of the same, apply the same concept here. If you have to find this vector BA within that triangle, you must have the magnitudes of two other vectors. Keep that in mind. So you must have the magnitudes of two other vectors to find the third vector. Okay? So if you don't have the magnitudes of two vectors on that triangle, then you have to find them. And then use your triangle law to help you to find BA. So how we using the triangle law? So I have the magnitude of two vectors. That's why I place them on the diagrams. I have the magnitude of OB, I have the magnitude of OA. So let's find BA. So part A. So I'm going to say here, using the triangle law. Alright? So based on my diagram, this is how the triangle law, we're going to implement it. We look to see which two vectors move in the same direction on your diagram. Which two arrows follow each other. And when two arrows follow each other, when two vectors follow each other, you always add them. So I'm going to, if I look at this diagram, I'm seeing vector OB follows vector BA. This arrow follows that arrow. And once two vector quantities, they move in the same direction, you add them. So I'm going to create an equation here. I'm going to say vector OB plus vector BA, because they both move in the same direction. And what you will always see happening when you use this approach, the two inner letters, just like what we did with matrices, and showing compatibility. You'll see for vectors, once you are using this very important formula out of the triangle law, the two inner letters are the same. That will always happen once you implement this approach. One vector follows the other. And what you're going to do is, once the two inner letters are the same, you connect the outer letters in that order to give you OA, your resultant vector. So vector OB follows vector BA, so you add them, and when you add them, you recognize the two inner letters are the same, and you connect the outer in that order to give you OA, vector OA, which is the third vector. So you have all three vectors on the diagram, in the formula, you know? OB plus BA will be equal to OA. But you want to find BA. So you have an equation there, the importance of equations. So to get BA as the subject, what I'm going to do is simply subtract OB from both sides. So just take that positive OB, throw it over on the right, and change the sign. So this will be OA subtract OB. Yeah? And the magnitude of OA, is what? 6.2. So let's substitute now. Subtract, the magnitude of OB is 3.4. So when I subtract, simple vector subtraction here, this is 6 subtract 3, and this is 2 subtract 4. So the magnitude of the vector BA will be 3, -2. So that's the magnitude of your vector B, right? So there's another approach we can use to find BA as well, you know, right? So there are two ways we can find BA. So you can, and I like to always advise students with vectors, it's always good to have that visual. So it's always good, especially with position vectors, to set up a nice little sketch and use the sketch to guide you so you can see, have that visual. So what some students may also do is this, and nothing is wrong in doing this. So besides using a sketch, you don't have to use a sketch. You can say, all right, to find BA, I can, with vector quantities, we have to learn this. If I have a vector going this way, this is OA. Good? And suppose the magnitude of this vector is, say, 2, 3. Just using an example. When you change direction, so with a vector quantity, you can move in the opposite directions. When you change directions, you're no longer moving from O to A, but you're moving this time from A to O. So this is OA, whose magnitude is 2, 3. But if you change the direction, what will also change? The magnitude will have to change. So the signs of each element in your column vector will change. So therefore, this will become AO. And what I'm going to do is to put a negative sign in front of 2, 3. So I'm going to change my signs. So this becomes negative 1 is understood outside. Even though the 1 is not seen, it's understood. Negative 1 by 2 is negative 2. Negative 1 by 2 is negative 3. But you can just simply change the signs of the elements within the column vector. So positive 2 becomes negative 2, positive 3 becomes negative 3. So something you have to know with vectors. So when you move in the opposite direction, the signs of the elements within your column vector will change. Alright? So this concept we're going to apply here to also get the same result. So we're going to say this. We have vector OA, we have vector OB. So look at the triangle law, the equation being implemented here also. So to get BA, it's going to be, instead of OB, I'm going to say BO. BO plus, you want BA, right? So BO plus OA. The two inner letters are the same, you'll always see that happening. And you can make the outer in that order. Will give you what? BA. So this is getting the same result without using the sketch and using the approach I implemented there. Look at to see which two vectors move in the same direction. You can say BO plus OA, two inner letters are the same, will give you BA. But we have to be very conscious of this. Remember, this is not OB, it's BO. So therefore, if it's BO, you have to change the signs of the elements within the column vector. So therefore, positive 3 now becomes negative 3. Positive 4 becomes negative 4. So that is now BO plus OA is what? OA is 6, 2. And when I work it out, when I add those two, it's going to be negative 3 plus 6 and negative 4 plus 2, which will give us 3, negative 2. So you got the same result for as the approach I used previously. Yeah? So that's finding B. So two ways of getting the same answer. So let's find now BC, vector BC. So BC. So again, having a visual, that visual. So to find BC, all I have to do now is to connect B to C. So let me connect B to C. So I'm going to follow through with this line here. Right? So you have some vector BC. Okay? And of course, with all vector quantities, you must put the what? Direction from B to C. Okay? So I'm going to use, again, same two approaches to find BC. So let me use the one on top. And again, this is also the triangle law as well. So let me use the triangle law. When I look at my sketch, does BC fall within a triangle where I have the magnitudes of two vectors on that triangle? If I look, BC falls within this big triangle here, OBC. See that big triangle OBC? And I have the magnitudes of two vectors on that triangle. I have the magnitude of OB and I have the magnitude of OC. So I have the magnitudes of two vectors on that triangle. So once I have the magnitudes of two vectors on that triangle, I can now comfortably implement my triangle law to find BC. Alright, and let me use the same approach as I did for BA using both methods. Alright? So let me write the result for BA here. And let's find the result for BC. So we listen. So B, using the triangle law, let's find BC. So I'm using this big triangle. So if we look, which two vectors move in the same direction on that triangle? OB follows BC. Once two vectors move in the same direction, and the arrows will indicate that once the two arrows follow each other, clearly you're going to add the two vectors so that move in the same direction or that follows each other. So I'm going to say vector OB plus vector BC. Two inner letters are the same, that will always happen, and I'm going to connect the two outer to give me OC. And therefore, after creating an equation, let me make BC the subject. So BC, vector BC is equal to vector OC. And I'll take this vector OB, throw it over on the right, and change the sign to negative OB. So that's me making BC the subject, and let me work it out. Let me replace OC with the magnitude 12, negative 2. Subtract, let me replace OB with its magnitude 3, 4. And when I work that out, what am I going to get? This becomes 12 subtract 3 and negative 2 subtract 4. And of course, 12 subtract 3 will be 9. And negative 2 subtract 4 will be negative 6. And that's the magnitude of the vector BC. So BC is 9, negative 6. Okay, so that's one approach we can use, or we can use the other approach, right? I use the diagram to help me to create that equation, or you can say here, I want to find BC, so I can say BO plus OC. Two inner letters are the same to give me what? Connect the two outer in that order, BC. And therefore, BO, and just remember to change the signs because students often, that's where they make the mistake when they use this approach. BO will now be negative 3, negative 4, plus OC 12, negative 2. And therefore, what are we going to get? This is negative 3 plus 12 and negative 4 plus negative 2 in brackets. And negative 3 plus 12 will give us 9. A plus by a minus is a minus. Negative 4 subtract 2 will give me negative 6. And that there is vector BC. Alright? So that's the other approach we can use to help us to get the result. Okay? And when stated here, state one geometrical relationship between BA and BC. Yeah? So what is the state a geometrical relationship between BA and BC? Good? So one geometrical relationship is this. Now if you look at BA and you look at BC, if you look, clearly we can recognize a proportional relationship between the two. If you look, BC, this is 9, this is negative 6, this is 3, negative 2. So I can see where BC is 3 times BA. So vector BC, so we're looking at one geometrical relationship. Let me erase here. So part 2, one geometrical relationship is simply this. If I look at BA and I look at BC, I will see where BC is 3 times. Vector BC is 3 times vector BA. So this vector is 3 times the vector BA. Vector BC is 3 times vector BA. And that's a geometrical relationship there. Good? So that's one geometrical relationship. BC is 3 times BA. Straightforward. You can see that. Yeah? And draw a sketch. We already did this sketch. This is a sketch here. See why it's important to know this sketch, the direction of the vector quantities. Alright? So this here is a position vector question. And we want to make sure we're clear on it. So let's look at let's see if we can look at another position vector. And then we look at right now, let's look at this one. Let's look at this one, especially where sometimes I like to ask questions in terms of the parallelogram. Alright? This one, right, sometimes I like to ask questions in terms of collinearity. Right, this one, sometimes I like to ask questions where the word midpoint will come into play. Alright? So let me see if I can look at this one. I also want to look at the one with the parallelogram. And then we look at a free vector, a displacement vector question. This is displacement, or sometimes say free vector. So you can see 2 types of vector questions. This is a displacement vector question, right? Let's look at this one first. I'll do one with the midpoint. Alright, so let's try to do that quickly. Let's see how quickly we can get that done. Right, so don't forget to, we're working until Sunday, so invite your friends, tell them come be a part of the sessions, make sure they can benefit as well from what we're doing here, and don't forget, to like, share, subscribe to the channel, okay? So, let's look at this. So I'm going back to that diagram is connected to this question, right? The diagram below shows 2 position vectors, OA and OB. See the position vectors there, right? What I'm going to do, let me redraw it so we can probably have a better view of it, right? So I have 1, 2, 3, 4, 5, 6. So visual is always important. This is -1, -2. We have 1, 2, 3, 4, 5 of the road. Yeah? Good. So you have 2 vectors. You have OA and OB, and OA moving 1 to the left and 3 upwards. That's A, OA. And of course, I must put my direction, the arrow. Let me put the arrow in red. And if we need to identify the magnitude, which I'm sure they will ask us in the question, and let's see. OB, as you clearly see, this is why I have to know the direction, the movement of the vector quantity. So you're moving 5 to the right and 1 upwards. Good? So 5 to the right from the origin, 5 to the right, 1 upwards. So this will be 5 to the right, 1 upwards. This is 1 here. So this is B. So we have vector OB. I have my direction. Good? And of course they connected A to B. So let's see what they ask us. They ask us, write as a column vector, remember that when you see X, Y, it's a column vector of OA, straightforward. So you know OA, so 1A, OA is clearly what? 1 to the left and 3 upwards. And when you're moving to the left of the origin, it's going to be what? Negative. And when you're moving upwards, it's positive. So this is what? -1, +3. So that's the magnitude of the vector OA, which you can see from the diagram as well. Moving 1 to the right, to the left, 3 upwards. Yeah, so that's the movement of the vector. Then we have vector OB. OB is what? Vector OB. 5 to the right and 1 upwards. You can see that from the diagram as well. 5 to the right, 1 upwards. So OB will be 5, 1. Let's see vector BA now. So we wanted to find vector BA. So to find vector BA, what we need to do, and they have it on the diagram there, BA, of course, we need to connect B to A. So we connect B to A. Alright? And on that vector quantity, I'm going to place my direction from B to A. So they should have your direction, alright? So to find BA, and you can do one of two things. Right? If this is on a grid, you can count the position. I'll show you, alright? I'll show you how you can do it that way as well. Okay? You can count the positions to determine the magnitude of BA, or you can use the triangle law here. Alright? We see a triangle, BA falls within a triangle. But on that triangle, make sure you have the magnitudes of two vectors on that triangle. And clearly I have the magnitude of OA, which is -1, 3. And I have the magnitude of OB, 5, 1. So I have the magnitudes of two vectors. So what I can do, I can use a triangle law. So you can say, and you can use both ways. You can say BO plus OA and work it out one time, right? Or you can use the triangle law. You can get familiar using this method too. Which two vectors move in the same direction? OB follows BA. And once they move in the same direction, you add them. So part C, using the triangle law, I'm going to say vector OB follows vector BA. Two arrows move in the same direction. What we see happening here, the two inner letters are the same. That will always happen. And I connect the outer in that order to give me OA. And therefore BA is equal to vector OA, and I simply bring positive OB over to the right as negative OB. And I can now work it out. So vector OA, the magnitude is -1, 3. Subtract vector OB, the magnitude, it is 5, 1. And therefore, we can get here as a result for BA, that is -1, subtract 5, and 3 subtract 1. So we're going to get here negative 6, 2. So the magnitude of BA is negative 6, 2. Or you could have done it the other way. You could have said BO plus OA will give you B. You could have done it that way too. And you know BO will be, if OB is 5, 1, then BO is negative 5, negative 1. And you know OA is negative 1, 3. So you have got BA as negative 5, a plus by a minus, plus negative 1, right? Plus by a minus is a minus, negative 1 plus 3. So if a plus by a minus is a minus, you know negative 5 subtract 1 is negative 6. And negative 1 plus 3 is 2. So you could have done it that way, right? To help to find the magnitude of B. Okay? So let's look at, or you can count the positions too. If this is done properly on graph paper, let me see. Let's check the diagram. So if I am BA, if I count, I'm moving to the left and I'm moving upwards. So let's move to the left, starting from B, starting point. Negative 1, 2, 3, 4, 5, 6. So I move 6 to the left, so that's negative 6. And 1, 2 upwards. So negative 6, 2. So you get count the positions too. Once it's a position vector question, you can count the positions to get the same answer. Alright? Okay, so let's look at the next. Right, so keyword I like to ask in vectors. Talk about midpoint. Given that G is the midpoint of the line AB, and what midpoint means in vectors, write as a column vector in the form XY BG. And then they want OG. So it states here, G is the midpoint. So in vectors, when you hear midpoint, if G is the midpoint, let me assume that that's G. What G will do, it will divide this vector, right? G is the midpoint of the line AB. It will divide AB in half. So it will cut AB in half. G is the midpoint of the line AB. So it will divide this vector here, AB, into two vectors, AG and GB. Alright? So it's going to divide the vector AB into two equal vectors, AG and GB. Remember, that's what midpoint means. So when you see midpoint in vectors, know what it means, right? So they want us to find BG. So we're going to find BG. We're going that way. Alright? Now because G is the midpoint, what G will do is to divide AB in half. Good? So if we divide this vector AB in half, it's going to divide it into vector AG and vector GB. So we can find vector GB, this is part 2. Vector GB, yeah? Well, to make it easy, because we found BA initially, this will make it easier. Previously we got what? BA, meaning I'm moving from B to A. So I'll keep the arrow that way, moving from B to A. We found that previously, right? And if G is in midpoint, it means it's going to divide this vector BA, moving in that direction, in half. It's going to cut it in half. So it's going to divide the vector BA into BG and G. Alright? So one time we can easily find BG. So let's find BG now. Because we have BA moving in that direction, and we found the magnitude of BA previously to be negative 6, 2. So because G is the midpoint, keep that in mind, it's going to divide BA into BG and G. And BG is a half of BA. So vector BG is a half of the entire vector BA. So look how easy we're going to find BG. So BG is a half of the vector B, which is negative 6, 2. Yeah? And when you find a half of negative 6, 2, a half of negative 6 is negative 3, and a half of 2 is 1. So BG, the magnitude of BG for 3, the magnitude of BG is negative 3, 1. Good? And now that we have found BG, so let me put BG on the sketch. That's why it's good to have a visual. BG is here. This is what? Negative 3, 1. Alright? I want to now find OG. I want to find OG. Now, where's vector OG on that diagram? So, with your vectors, I will always advise have a visual. So, you want to find OG. So, it means I'm going to connect O to G. Good? So, I want to find OG now. So, let me put my direction on that vector quantity. Good? And to find OG, which is part B, we first check to see if OG falls within a triangle where you have the magnitudes of two vectors on that triangle. And when I look, I see that OG falls within two triangles. You have this triangle OGA and you have OBG, those two. Anyway. And any of the two you can use that. Any of the two you can use that to find OG. So I will go with this triangle here on the right, because I'm seeing clearly I have the magnitude of OB and I have the magnitude of BG. So let me use that now to find the magnitude of OG. Alright? So therefore, to find OG, I am going to implement my triangle law. Yeah? So again, on your triangle, you look to see which two vectors follow each other. And which two follow each other on this triangle. So I'm going to say here vector OB follows vector BG. This arrow follows that arrow. They both move in the same direction. So I'm going to say here vector OB plus vector BG. What will always happen? The two inner letters are the same. That will always happen. And that will give me vector OG, which is what you want to find. So vector OB plus vector BG gives you vector OG based on my direction of the vectors, which two vectors follow each other. Make sure the arrows on your vector quantity is going to help you a lot if you're using this approach. And therefore OB is what? 5, 1. And BG is negative 3, 1. When we work that out, what we're going to get OG to be equal to? OG will be, this will be clearly 5 plus negative 3. And I put negative 3 in brackets, and 1 plus 1 will be equal to OG. And that now becomes 5 plus negative 3, plus by minus is a minus, 5 minus 3 is 2, and 1 plus 1 is 2. So vector OG is 2, 2, 2, 2, right? So that's the magnitude of your vector OG. So make sure with keywords and vectors, when you see midpoint, what midpoint means? It means that point will cut the vector in half. Good? Given vector in half. Okay? And then you work from there to help you. Alright? So let's see. So I'll just do, I'll do 2 more questions. Alright, what I'll do, let me do let me do a displacement vector question. So I'll do this one. Right, I'll do this displacement vector question. So just to bring your displacement vectors to mind, same use of the triangle law. This time your answers will be in terms of letters of the alphabet. So it wouldn't be in terms of your column vector. Alright? So the column vector will be applicable to position vectors. So we're looking at a displacement vector question. So let's look at this here. So I'm going to erase all this information and so two types of vector questions you can see in your exam, and let's make sure you know how to treat with them, right? So after the displacement, I'll look at one more, I'll look at another position vector with the parallelogram. So you know how to treat with questions if they ask you about the parallelogram, and we will close off, right? Tomorrow we'll be looking at transformations. I'll include some quadratics, some linear programming. Friday I may do some statistics. Saturday some statistics. We'll do functions. We'll look at the early part of the paper, right, on Saturday, Sunday. So hopefully I may want to redo that video from the first day, seeing that we had some challenges there, so we want to redo that video on the first day. Alright? So let's see how we can work it. Alright, so this here is a displacement vector question. Again, in the diagram below, OPQ is a triangle. So you see that OPQ is a triangle. ARB and AOQ are straight lines, which we see. Now let the word came up again. B is the midpoint of PQ. So B is the midpoint of PQ, meaning B will divide that vector, that line or that vector PQ in half. Yeah, into two equal vectors, PB and BQ. If B is the midpoint of PQ. R is the midpoint of AB. R is the midpoint of AB, meaning R will divide that line AB or that vector AB into two equal vectors, AR and RB. OR, now, very important. OR to RP, you have a ratio. What the ratio means. OR to RP is 1 to 3. 1 to 3. Good? And you need to understand what the ratios mean. So this simply means that this is what you do. Add 1 to 3, which will give you 4. And you're simply going to state OR is a quarter. OR. So you add the two proportional parts, right? 1 plus 3 is 4, and therefore it will indicate OR is a quarter of this entire vector OP. Alright? And RP will be, you simply going to put 3 over 4, RP is 3/4 of the entire vector OP. So OR is a quarter, just add 1 to 3 to give you 4, and you get 1 over 4, quarter of the entire vector OP, and RP is 3/4 of. And if you add a quarter to 3/4, it gives you the whole line, that's all, whole vector OP. So understand when we see the ratio OR to RP understand what that means. It means this. Alright, 1 to 3. That is what that means. Okay? And also they gave us the magnitudes of the vector OP and OQ. So vector OP, this is vector OP. So let me put my direction one time on my diagram. Vector OP direction has magnitude 4a. So that's the magnitude of this vector OP. Good? So the magnitude of the vector OP, it is 4a, going from O to P. And the magnitude of the vector OQ, so put your direction from O to Q, the magnitude is AB. Okay? So make sure you place your direction and your magnitudes on the diagram. Alright? So now what I want us to find, let's see what I want us to find in this question. Find in terms of A and B. So your answers have to be in terms of A and B. Alright? Not a column vector, not a position vector. PQ. So let's find PQ. Now where is PQ? This is PQ here. So this is vector PQ. Let me put an arrow showing the movement from what? P to Q. Good? Now if you want to find PQ, we're going to use the triangle law. So I'm writing here using, so this is 1. To find PQ, I am stating here using the triangle law. And in using the triangle law, I look to see if PQ falls within a triangle. And if it does, if you look, OPQ, you see this triangle here? And make sure that you have the magnitudes of 2 vectors on that triangle, which you do. You have the magnitude of OP, which is 4A. You have the magnitude of OQ, which is AB. So when you're using the triangle law, make sure you have the magnitudes of 2 vector quantities on that triangle. Yeah? So let's use the triangle law to find PQ. And again, I'm using the approach where we can say PO plus OQ, no problem, you get the same answer, right? Or you can look to see which 2 vectors move in the same direction on that triangle. Which 2 vectors follow each other. And if you look, OP follows PQ, the arrows follow each other, they move in the same direction. And when 2 vectors move in the same direction, you add them. So you're going to see here vector OP plus vector PQ. You'll always see where the 2 inner letters are the same, and it's going to give you OQ. And now you can make PQ the subject. So PQ, take OP, throw it over on the right, change the sign, will be equal to OQ, subtract OP. And vector OQ, the magnitude it is AB, subtract vector OP, the magnitude it is 4A. So the magnitude of the vector PQ is 8b subtract 4a. Let me put it on the diagram so we can see the magnitude of PQ, 8b subtract 4a. Alright? So that's the magnitude of that vector PQ which we have found there in terms of A and B. Now let's look at the next part. They want us to find now PR. Good? So let me go back to the diagram. PR. So the one that's find PR, this is PR here. PR. So it's supposed to be going in that direction, right? But what we can do here, we can find RP. Alright, because remember we had a ratio of OR to RP is 1 to 3. And RP is 3/4 of the entire vector quantity. So what you can do, they ask you to find PR, let us find RP first and then change the direction. Okay? And of course change the sign of the magnitude. So let's find RP first and then we will find PR. So what is RP? So looking at part 2. So let's get RP first. So part 2. RP, vector RP, because of the ratio, we know vector RP is 3/4 of vector OP. And we know vector OP, the magnitude is 4a. So that is 3/4 of 4a, which is 3. So the magnitude of RP is 3a. And if the magnitude of RP is 3a, therefore the magnitude of PR, we're moving in the opposite direction now. We're going to change the sign of the magnitude to -3. So you know PR will be -3. So the magnitude of PR, -3. And let's look at the last part here where they want us to find RB. So to find RB, let's see where is that vector RB. So RB is here. So see vector RB, so I place the direction on the vector quantity, so it's in the arrow. So RB, let's see, does RB fall within a triangle? Yes. What triangle it falls within? This triangle here, RBB. And what you want to do is to ensure that you have the magnitudes, when you're using the triangle law, make sure you have the magnitudes of 2 vectors on that triangle so you can find the third vector. So let's see, we have the magnitude of RP, we just got, well, RP we know is 3a. So RP is 3a. That's the magnitude of RP, 3a. And we can also find the magnitude, we don't have it yet, but we can find it, the magnitude of PB. Remember we want to find RP, right? RB, sorry. So we must have RB, yeah? So we must have the magnitudes of 2 other vectors on that triangle. So we know RP is 3a, and we can find PB. So how are we going to find PB? So we're looking at part 3. So PB, let's get PB first. Because it told us B is the midpoint, keyword midpoint, it means if B is the midpoint, it means that PB is a half of PQ. Yeah? And we got PQ previously, that's why I wrote the magnitude on the diagram, so always got to write it on the diagram. The magnitude of PQ is 8B minus 4A. So you know PB is a half of the magnitude of PQ, which is 8B subtract 4A. So a half of, and remember we're going to put that 8B subtract 4A in brackets. I'm going to say a half times that. We'll just write it like this. So when you're multiplying by an expression with 2 or more terms, you have to make sure. You can't just multiply half by PQ 8B minus 4 and write it like this. You must put the 8B minus 4A in brackets, showing a half times the entire expression. So let's multiply half by 4B, 8B, sorry, will be 4B, and a half by negative 4A will be negative 2A. So remove your brackets. So you know that PB is 4B subtract 2A. So you have the magnitude now of PB. So having found the magnitude of PB, let me introduce my triangle law. I look to see which two vectors follow each other on that triangle to assist me in finding RB. And when I look at that triangle, I see where this vector follows that vector, this arrow here. Good? Those two vectors move in the same direction, they follow each other. That arrow follows that arrow. And when two arrows move in the same direction, two vectors move in the same direction, you add them. So you're going to say here, vector RP plus vector PB. What we see happening here, two of the letters are the same and will always happen, will give us what? Vector RB. And RB is what you want to find, so RB is already the subject, yeah? So there's no need to make it the subject, it's already the subject. So we're going to replace RP with 3A, plus we're going to replace PB with 4B subtract 2A. Is equal to RB. What we can do here is group like terms. This will be 3A subtract 2A plus 4B, and 3A subtract 2A will give us A plus 4B is equal to RB. Good? So this here is a question in relation to your displacement vector. Alright? So again, the use of the triangle law, the use of the word midpoint. Just keep in mind your magnitudes will be in terms of the letters of the alphabet, in this case A and B. Alright? So right, so I want to do one more question. So let's do one more. So we'll do a position vector question, but this one will be where we have to prove that OSTR is a parallelogram, right? So we want to make sure we understand we have a parallelogram, how to treat with that. Okay, let's look at this last one and we call it a night. Okay? So we're looking at some erasing. Right, the diagram below shows two position vectors, OR and OS. You see the two position vectors, OR and OS. Such that now R 6 2, that's just the point R. We plot this point R, right? And S, we plot that point negative 4 3. Now what is represented as a column vector, that represents the what? Movement of the vector. Alright? So they want us to write as a column vector in the form XY. Let's look at part 1. Vector OR. So that should be easy. Vector OR will be moving from the origin 1, 2, 3, 4, 5, 6 and 1, 2 upwards. So vector OR will be 6, 2. Okay? Next they want us to find vector OS. Vector OS, this is vector OS here. So this will be what? I'm moving to the left of the origin. So this is 1, 2, 3, 4. So that will be negative 4. And I'm moving 1, 2, 3 upwards. So therefore OS will be negative 4, 3. And then we have vector SR. So where is SR? So in order for us to find SR, what we need to do is to connect S to R. So that's me connecting S to R there. And what I'm going to do is put the direction. Right? From S to R. So to find SR, we can count the positions, so you can say what? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 to the right, positive 10, and 1 down, 10, negative 1. But you can also use the triangle law. So we know OR is 6, 2, and we know OS is negative 4, 3. You can use the triangle law because we have a triangle and you have the magnitudes of two vectors on that triangle to help you to determine the two. So I'm going to say here using the triangle law, part 3. And of course to find it, we can say, we just define SR, we can say SO plus OR. And you get it? Easy. Or you can look to see which two vectors move in the same direction. So I'm saying using the triangle law, I'm going to say OS follows SR. So I'm going to say OS plus SR, those two move in the same direction, so you can add them. You'll see that the two inner letters are the same, and you can add the outer to give us what? OR. And therefore, SR is equal to OR. Positive OS comes across as negative OS. And OR, we know it's 6, 2. Subtract OS is negative 4, 3. So we're going to get what? This will be 6 subtract negative 4, 2 subtract 3, which will be a minus by a minus is a plus. We're going to get 10, negative 1. Same as when we counted. 10 to the right, 1 downwards. Or you could have used SO plus OR and you would have gotten the same result for SR. Alright, so vectors, we use of the triangle law, very important law to help us. And let's see, they ask us now, now what does this mean in vectors? So part 4. Now they want us to find those two parallel lines on either side of OS is called the modulus. The modulus means that the magnitude of your vector OS, which is the size, remember magnitude means size, you can actually determine what's the size, what's the actual length or size of that vector quantity, yeah? And the modulus means that the result will always be positive result. And to determine the magnitude in a vector question, once you see those two parallel lines in a vector question, this is what we're going to use to determine the magnitude of the vector OS. So this vector OS here, what's the magnitude of that vector OS? We use this formula, square root of x squared plus y squared. So get familiar with that. Very important formula we use to determine the actual size of the vector quantity. Yeah? So we know that OS, the magnitude is negative 4, 3. We know that's the magnitude of OS. So I'm going to replace x with negative 4 in bracket squared, and I'm going to replace y with 3 in bracket squared. So I'm going to get here the square root of 16 plus 9, which is the square root of 25. Which will be, and we state 5 units, right? Because it's a measurement, yeah? So 5 units will be the magnitude of the vector OS. So when you see those two parallel lines, that is the formula you use, good? To help you to determine what's the magnitude, alright? Alright, let's look at the last part of this question. Given that OT has magnitude 2, 5. Column vector 2, 5. Prove OSTR is a parallelogram. So they want us to prove. So we have T now, so we have to introduce T. And we want to prove that OSTR is a parallelogram. So T has magnitude 2, 5. So let's place T on that diagram. So what I'm going to do is to erase here. So let's find T. T is what? 2. T is O. Right, OT is 2, 5. Vector OT. So it means we're moving 2 to the right, 1, 2, and 5 upwards. 1, 2, 3, 4, 5. So that's T. Good? So that's the position of T. And therefore, what we can do is to create a parallelogram. OS, and we connect S to T. And let me connect T to R. So you see the parallelogram there? So this is a parallelogram. A parallelogram is formed from, you have a rectangle, and you take 2 sides and tilt them at the same angle. This is what you're going to get. That is a parallelogram. Alright, now with a parallelogram, the 2 opposite sides are always equal and parallel. These 2 opposite sides are also equal and parallel. Good? So that concept we're going to apply here, because if they ask us to prove that OSTR is a parallelogram, what are we going to do to prove it's a parallelogram? This is what we do to prove OSTR is a parallelogram. So this is part 5. So OSTR is a parallelogram. And why? Because if we look, the magnitudes, remember in order for it to be a parallelogram, 2 opposite vectors must be equal and parallel. Equal and parallel. The magnitude of this vector RT would be TR, because this is what? OS, so this will be RT. So make sure direction is this way. Alright? RT, and RT will be what? We can count it. If you look, I'm counting negative 1. This is 1, 2, 3, 4 to the left, so that's negative 4. And 1, 2, 3 upwards, so this is negative 4, 3. That's the magnitude of RT. And this is what? OR, then we're looking at the magnitude of ST. So they can be what? Parallel, moving in the same direction. And what are their magnitudes? The magnitude will be what? Let's see, we're also going to get 6, 2. So I'm counting 1, 2, 3, 4, 5, 6. 1, 2. So it's 6, 2. So clearly, opposite vectors are equal and parallel. Good? So for the parallelogram, we can say here vector OS is equal to vector RT, whose magnitude is negative 4, 3, and vector OR is equal to vector ST, whose magnitude is 6, 2. But then what you also have to show your examiner to prove and show that they are parallel, you're not just going to stop here, you have to also show this to prove that they are parallel. Remember, these two lengths are the same, the lengths are the same. and we just looked at the modulus, right? Two parallel lines on either side of the vector, so you have to show them that. So the modulus of OS is equal to the modulus of RT, alright? And we can work that out by simply doing this. The square root of x squared plus y squared, both will have the same length. So this is proving they are parallel. This is the square root of 4 all squared, negative 4 all squared, plus 3 all squared. Square root of 16 plus 9, square root of 25, 5 units. So each one of these vectors, OS and RT, will have a length or magnitude of 5 units. So you're also showing them that to prove they are parallel. And you do the same thing for OR and ST. So the modulus of OR is equal to the modulus of ST. Remember the two parallel lines, we call it the modulus. And this is the what? Square root of x squared plus y squared, which is the square root. And replacing x, we're looking at OR and ST, x with 6 in bracket squared, and plus y with 2 in bracket squared. This is the square root of 36 plus 4. 36 plus 4 is 40. And of course, you can find the square root of 40. The square root of 40. 6.32 units. We want to leave it at 2 decimal places. So the length of OR and ST both are 6.32 units. So we have proven or shown, so therefore, hence, proven OS TR is a parallelogram. Alright, I should put hence, not proven, but hence, it asks us to prove. Right? Hence proven OSTR is a parallelogram. This is how we show that and prove that it is a parallelogram. So take note. Alright, so this will bring us to the end of day 2 of our revision exercise. So we meet again tomorrow. Tomorrow we're going to look at some transformations, some quadratics, and also try to include some linear programming. Yeah, again we meet Saturday, and the last day will be Sunday. So I'll try my best to redo day 1, seeing that we had some issues with the video and the audio. So I'll try to redo day 1, but we're going to continue jamming, to continue pushing until Sunday, and we can enter that exam with confidence and do an excellent people. Alright? So that's it. Have a great night, everyone. See you all tomorrow. Take care.